Yeah, Boca Decimal morning. So we grade 10, grade 10s, grade 10s, calling on all grade 10s, right? Calling on all grade 10s. Boca Decimal, how about grade 12? Please check the schedule. I don't know how many times I need to tell you guys, but check the schedule. But not more than that, I posted a video. There's a specific video I posted for grade 12s, okay? And grade 11, I've also look at the schedule, okay? So 8:30 now I'm going to have grade 8:30 I'm going to have grade 10s. We're going to be looking at more products, meaning more multiplications, more and mixed problems on that, and then we're going to start factorization at 8:30, which is now, and then 10 a.m. grade 8, 1 p.m. we have the grade 11s. At 4 p.m. today, first session for grade 12. All right. Then another thing, grade 10s, the WhatsApp group is up and running, all right, and I hope that those who are who are in that WhatsApp group already, would just make it a point that you make yourselves visible on the comment section. Yeah, I think if you are actually in that group, please make yourself visible so that those who may want to be part of that WhatsApp group can be part of it, so that whenever there's specific material, even during the course of the year, that relates to your grade and things that maybe we would share with you guys, then we can share those things specifically to you in the group. But also, any sort of like motivation, also just being part of a community of learners in grade 10 that have chosen pure maths, that helps a lot. You guys can help each other as well. You can assist each other. Just notify your parents about the group. It is a group that's there for the purpose of like assisting and building and strengthening, because I do understand that a lot of people that take pure maths grade 10, and I want to spell this out from the beginning. Grade 10 pure maths, guys, is, if you've chosen to do pure maths in grade 10, you must make sure that you are someone who is equipped to do that grade 10 pure maths. I hope you're not simply doing it because your friends are doing it, or simply because maybe, I don't know, I know in some schools you are either in the A or B class, depending on whether you do pure maths or you don't. So some kids just do it for status. They don't do it because it's genuinely, pure maths that they're good at. They do it for status, and then what ends up happening is some of them, they fizzle out, or they don't take it seriously, and then they don't do as well. And some kids, if I was to be honest, are not meant to actually choose pure maths. They're supposed to be choosing maths literacy, but they don't choose pure maths. Or let me say they choose pure maths, like I said, for reasons that are not legit. So please, if you are doing pure maths grade 10 next year, make it a point that you do join in these sessions, okay? 2, you do subscribe to the YouTube channel so that in the case that you miss a session, you can always go to the YouTube channel, Maths is a Game, and actually rewatch the sessions that we've covered and done already. Okay, we've already started like last week already, or the week before, with grade 10 maths. So we've progressed to this point now where we are doing products, and we'll be starting with factorization. But understand that we've been doing this, we've been at it, all right? So you need to actually try and catch up so that you can be at a place where we are all going together. Much of what you do in term 1 is similar to what you have already done in grade 9. So there's nothing really new in the beginning. Yes, this also, it's free, all right? I do though accept people sending gifts, obviously, on the live TikTok session when we do have it. I mean, whatever you can give, it's fine, all right? But in essence, it's free. I'm not asking you on the side to pay a certain amount of money or something like that. This is just literally being done so that I can actually serve you and help you, and hopefully you can kind of have someone who can walk the journey with you from grade 10 hopefully up until grade 12. But also, more importantly, we want people to actually do exceptionally well in maths, not to get level 1, BOMA level 2, BOMA level 3. That's nonsensical levels, and I'll say it from the get-go. If you are in this, if you are joining these live sessions, please understand, I'm not teaching people here so that at the end of the day they can get level 1 and 2 and 3 and 4. Okay, to me, that's nonsensical levels if you're getting level 1, 2, 3, and 4. All right, and I include the level 4 there. You should have a standard set to try and get above level 5 in your mathematics journey throughout grade 10 to 12. Okay, and that's basically where we are hitting. The minimum standard is level 5. 6 and 7 are basically where we should be looking at. 5, 6, 7. Level 4, 3, 2, and 1 are nonsensical levels for any grade 10 learner. So we should not aspire for that. We should not shoot for that. It shouldn't be even something that we should be looking in the direction to. Okay. So like I said, hopefully you've made the right choice by choosing pure maths next year for grade 10. But if it does happen that you see that you are struggling, and genuinely you are struggling, please humble yourself, change pure maths whilst you still can, and then go and do maths literacy. There's no shame in doing that, but you will actually be shooting yourself in the foot if you are going to continue to do pure maths, but you obviously, and you can see that you are genuinely struggling. Okay, so I just want to say that from the get-go, all right, so that we do not we don't fool ourselves. More importantly, all right, it's more important that we do what will benefit us at the end. Then also remember, the live sessions, when I do the problems and I do them well, that's me, it's not you. So when I do something and I cover it, I usually will post a homework problems or homework problems to do. I call those homework problems game challenges. You have to do those. And if you are part of my WhatsApp group community already, then please make it a point that you find a way to send me your work, what you've done, so that I can see what you've done and I can see that there's something that's happening that's positive. You are learning something, you are progressing in some sort of positive direction. Okay, please guys, this is so important. You sitting here and seeing me do the work is not good enough. You need to also have a pen and a paper, actually a book by this point, so that you can write down any notes that you feel are important, and then also make it a point that you are there. So Fenze, I see you want to join the WhatsApp group. So those who are actually in the WhatsApp group already, because there are people who are in the WhatsApp group, just make it a point that you are able to pick up Fenze so that Fenze can be given the WhatsApp link and so forth. I'm sure guys that are already there will actually send you a message on the side so that you can actually make it a point that you are part of that. So please, all those guys in grade 10 that are already in the group, I think Rowan is there. I think Smart Study is also there, if I'm not mistaken. Okay, there's a few people that are actually already there. make it a point that you guys please pick up these individuals that are actually indicating that they actually want to join. Okay. Because you see, for instance, people are saying they've tried, but they've not been added. Okay. Or you guys can actually send me, just TikTok message me on the side and send me a message with your name and your number, and I'll add you onto the group. Okay. All right. Yeah. So, like I said, this is a free opportunity. Sometimes when people get things for free, they tend to take them for granted. All right. But I want you guys to not take this for granted. This has value. All right. Maybe if I was making you guys pay a handsome amount of money, then you'd feel the value of what I'm doing. But you don't need to pay that amount of money. You need to actually just take the session seriously and yeah, do your part. You'll be fine. All right. Okay. So now I think I need to jump into the session. Let us start. So last week last time we met, we started doing products. And by that I mean multiplication of a single term with two terms, multiplication of two terms with two other terms, multiplication of two terms with three terms. All right, we started doing that, and we looked at that, and I would say, in my estimation, it was going nicely. But like I said, I want to encourage you guys to actually do some work on your own, please. All right, so let us start, guys. Yeah, so like I said, if you want to join the group, just make sure to send us an inbox. Yeah, you can inbox Sloane, you can inbox Snokutle, all the people that are indicating there, inbox them. It's for maths, guys. Unfortunately, life science and physical science we don't have. But I think as soon as you guys are able to establish a community of like learners there in that group, then you guys can actually communicate amongst each other and assist each other. And then maybe if there are other groups that do prop up that you guys are aware of that have to do with other subjects, then you guys can actually refer each other to those respective subjects. But it's good to start at this place where you actually have this group where you guys can communicate, and then you can take it up and see what other groups may be available for other subjects and assist each other. Okay, so yeah, let's take it one step at a time. Then yeah, we should be good. So guys, like I said, I'm just going to look at a few examples that I did of what I did last time so that we can be on the same page. But please do go to the YouTube channel, Maths is a Game it's called. I have already uploaded the sessions for what I've done previously in previous sessions, so you can actually go on there and watch those sessions that we've done for what we've done previously. So I'm going to pick things up from where I left off. I'm not really going to review what I've done already. So it will be up to you to actually go ahead to the YouTube channel. It's called Maths is a Game. You can go to my bio. The link, in actual fact, the YouTube icon that's there, you can click on it and it will send you directly to the YouTube channel, and you can actually check out the sessions I've done previously. So I'm going to move on today. And yes, what you are going to find is that the work we are doing is very similar to what you did last year. So we are going to continue with products, okay? And we are going to look at mixed problems where products are concerned, okay? All right, so let's go. 5x minus 3x into 6 times 2x. Okay, let's check this out. Right. So now look at this problem. First and foremost, we look at this and we ask ourselves, how many terms do we have in this expression? That's where we start first. Okay, how many terms do we have in the expression? So remember, from grade 9, you guys learned that, in grade 8, you learned that minus and plus, your addition and subtraction sign, are what separates terms from each other. So how many terms do you have? You have 5x, that's one term. This minus sign will separate the 3x together with the 6 times 2x. Remember, brackets combine terms. Multiply also combines terms. So that means you have 3x into 6 times 2x. This here is one term. So you have 5x, which is one term. This minus sign separates the 3x into 6 times 2x. So in other words, you have how many terms in total? We have 2 terms. Now, 2, remember what we refer to as BEDMAS. Okay, I even say now it's actually referred to as BEDMAS. In other words, the order of operation whenever you have different types of signs or different types of operations is you need to first look at the brackets, you look at the exponents, division, multiplication, addition, and subtraction. So because there's 2 terms, we need to take into consideration BEDMAS. We can't just proceed however we want. So for instance, I know some people would fall into the trap of thinking that 5x minus 3x is equal to 2x, and then they take the 2x and they distribute it into the bracket. This is not the case. Does BEDMAS allow me to do subtraction first before I take care of multiplication? Definitely not. So that means I need to take into consideration BEDMAS whenever I have different operations. I hope you guys are understanding me and we are together. Okay, so we need to take into consideration BODMAS if we have different operations for a particular expression. Okay, so let's go. So first step, 5x, we're going to actually leave 5x for now. Okay, then minus 3x, we're going to leave minus 3x for now. We're going to focus on this bracket because BEDMAS or BODMAS says brackets first. What's 6 times 2x? If we multiply 6 times the 2x, remember when we multiply two things, we need to take into consideration the sign, the number, the letter. Sign, positive times a positive is positive. Number, 6 times 2 is 12. Letter, x. Okay, that's where you would start. There would be a mark for that. All right. Now imagine someone who said 5x minus 3x and wrote 2x. Big mistake, right? Because BODMAS does not say we start with subtraction. Subtraction comes later on in our order, right? So we start with the bracket and we multiply what's in the bracket, because brackets here we need to multiply 6 and 2x, we get 12x. Moving right along, 5x still stands, don't touch it yet. Negative 3x times 12x. Remember, brackets mean multiply. Right? So in our order of operation, after brackets, we go on to exponents, no exponents, division, no division, multiplication. There's definitely multiplication. 3x times 12x. In fact, it's negative 3x times 12x. This is grade 10. Negative 3x times 12x. What's negative times a positive? It's negative. The sign is complete. 3 times 12, 36. Letter, x times x. Remember, this is x to the power. Remember, there's an exponent 1 and there's an exponent 1. So that means 1 plus 1. So final answer, 5x minus 36x squared. Can we subtract these two? Are these like terms? No. So can we simplify any further? No. Because the variables have different exponents. The exponent here is 1 and the exponent here is 2. So we cannot subtract unlike terms. These are unlike terms. Why do they qualify as unlike terms? It's because even though the variables are the same, the exponents are different. So therefore these are unlike terms. Are we together? Okay. All right. So let's review what I've just did, all right, for this problem. First, looked at the expression, asked myself, how many terms? There are 2. What do I have in my 2 terms? I have a 5x, and this second term I have 3x into 6 times 2x. So what do I then do? It means that I need to apply BODMAS, or in other words, BEDMAS. Brackets first, so obviously 5x stays, negative 3x stays. I multiply with 6 times 2x. What's 6 times 2x? It's 12x. Okay, because when I multiply, I consider the sign. Positive times a positive is positive. The number, 6 times 2 is 12. The letter multiplied, the x is combined, the 12. Okay, then the bracket is still there. Next step, 5x still, we hold it, minus. Now 3x times 12x needs to be my next order of operation, multiplication, because brackets mean multiply. What's negative times a positive? Negative. What's 3 times 12? The number? 36. What's x to the power 1 times x to the power 1? Remember, whenever we're multiplying same bases, we keep the base x, we add the exponents. We have exponent 1 and exponent 1. So we add the exponents, we get x to the power 2. Okay. Then here, 5x to the power 1 minus 36x to the power 2. Can we subtract? No. Why? These are unlike terms. Why are they unlike terms? Because this x has an exponent 1 and this x has an exponent 2. So subtraction and addition cannot happen. So unlike terms cannot be added or subtracted. That's what you learned in grade 9. So therefore our answer is 5x minus 3x squared. And that's where we end. We can't go on any further. Right? Okay. Can I move on to the next problem? So this would be a typical, what do they say? This would be, they would say simplify. Okay. So here what we are doing is we are expanding and simplifying. Okay. Okay, let's look at another example. Example number 2. 5x minus 3x into 2x squared minus 3x plus 4xy minus 2y squared. Again, look at the expression. First question we ask ourselves, how many terms do we have in the expression? So, this is 5x, one term, minus separates the term. So this is 5x minus, there's a 3x into all of that. So in total we have how many terms? We have 1, minus sign separates, 3x into that. So this is 2. So we have 2 terms in our expression. Very important. 2 beautiful terms. So how do we proceed? BEDMAS. Where do we start? Can we say 5x minus 3x? Definitely not. Even though we can see these are like terms, but remember it's not like terms because this 3x is in a committed relationship with this bracket. It is influenced by everything else that's here. So these are not like, we cannot subtract. BEDMAS says we cannot proceed with subtraction. 3x, negative 3x needs to be multiplied to these 1, 2, 3, 4 terms inside this bracket. Are these terms like terms? X squared, x, xy, y squared, no. So therefore we cannot even add and subtract what's inside these brackets. So where do we start then? It means we are going to have to write down the 5x minus, take the negative 3x and distribute it to all 4 terms inside the bracket. We use the distributive law. We distribute negative 3x by multiplication using sign, number, letter multiplication. So let's start here. Please don't forget this sign. This sign also gets distributed. This is negative 3x times 2x squared. So what's negative times a positive? It's negative. That's the sign. Move on to the number. 3 times 2 is 6. Move on to the letter. X times x squared. We keep the base x. Then what do we do when bases are the same? When we are multiplying, we add the exponents. There's an exponent 1, remember, don't forget that. Like I said last time in the live session, it's like the unseen entity that rules over all. 1 plus 2, that's our exponent. We are done with negative 3x times 2x squared. Now we're going to look at negative 3x times negative 3x. Negative times a negative sign, positive. Move on to the number. 3 times 3 number, 9. Move on to the letter. X times x, x to the power 1 plus 1. Guys, I'm doing this because I want you to see that with the exponents, you need to be able to add those exponents. I know some of you already do it in your heads. You would have already written negative 6x to the power 3. That's great. But I'm just doing it for those who do not take that into consideration. Okay? Let's move on to the next one. Negative 3x times positive 4xy. What's a negative times a positive? That's negative. I hope you guys are answering with me. You are actually writing down your own books, or maybe the answer is already written down. Number 3 times 4. That is 12. Then x to the power 1 times x. That's also to the power 1. Remember, that will be x to the power 1 plus 1. Then we have a y here. That's not complemented by another y. That will be a y combined with the x. Next door to the x, we write the y. We are done with the third term. Now, negative 3x times negative 2y. Sign, number, letter. Sign first. Negative times a negative. Positive. Number. 3 times 2. 6. X to the power 1 times y squared. That will be x, y squared. The letters are written combined next to each other because they are different. Okay? Then, let us just take care of our addition of exponents there. So 5x minus 6x cubed plus 9x squared minus 12x squared y plus 6xy squared. Let's look at these terms. Are there any like terms? 5x, 6x cubed, that's negative, x squared y, xy squared. Seems like we have unlike terms. So that means that we leave our answer like this because we have unlike terms. We cannot add or subtract unlike terms. Yes, Olerato, wanted to ask about the terms in the sequence. I know that terms are separated by plus or minus sign. I don't understand minus. I don't understand what you're saying now. Q minus and I wrong. I don't know what you mean by that. I heard your comment there. I just want to ask about the terms in the sequence. I know that terms are separated by a plus or minus. Yes, they are. They are separated by a plus or minus sign. Terms are separated by a plus or minus sign. You are correct in saying that. Yes, terms are separated by a plus or a minus sign. They are. Like Boshi, I do not do physics. I do maths. This is a maths channel. So you're going to have to find a TikToker that does physical science. I don't do physics. How do you see that terms are unlike? So Pearl Star, in your grade 8 and 9, you should have been taught very well to know when terms are unlike. Okay? So terms, how do you know terms are like? Let's start there. Like terms have the same variable and exponent. Okay? The like terms have the same variable and exponent. So for instance, if you have 6x, if I say 6x plus 3x, okay, it's like they are kids wearing the same uniform. Those are like, I mean, if you have kids in a school wearing the same uniform, then you know those are kids from the same school. Kids from the same school are like terms. They are in the same school. So 6x and 3x, x and x are exactly the same. All right. These are two terms. They're separated by a plus sign. So 6x and 3x are like terms. You can add and subtract like terms because the variable base, which is x, and the variable base, which is x, is exactly the same. So the answer here would be 9x. 6x squared y plus 5yx squared. I wanna see if you guys can see what I'm saying. So let's look at the variable. This is x squared. Look at the side. This is also, we have a x squared. This side we have a y. We also have a y. Are these like terms? Yes, they are. Why? Because even though the order, you have x squared here, you also have x squared there. You have y there, you have y there. Multiplication is commutative. In other words, the order of the variables doesn't matter. What matters is, do we have an x squared? Yes, we have an x squared here as well. Do we have a y here? Is it to the power 1? Yes, we also have a y, and it's to the power 1. So these are like terms. Can you add these like terms? Yes, you can. So the answer here would be 11x squared y. Doesn't matter the order of the letters. We usually take the order of alphabetical order, which kind of helps us out, but doesn't really matter the order. What helps us identify that these are like terms is the variable and the exponent being the same for both terms. That's how we know it's like terms. But the minute, look at this, 5x, 3x squared. Now, you're going to look at this and be like, okay, so this is 5x, this is 3x squared, this is x, but there's x here and there's x. How many terms do we have here? 2 terms, because they're separated by a plus sign. There's an x here. What is the exponent? The exponent here is 1. You don't see it, but it's there. There's an x here as well, but look at the exponent. The exponent is 2. So these, are they like terms? No, they are not, because, guys, the exponents need to also be the same in order for us to acknowledge them as like terms. So if the exponents are not the same, guys, they are not like terms. All right? Are you with me? It's not enough that the variables look alike, but the exponents as well need to complement, all right, each other. They need to be exactly the same in order for us to acknowledge them as like terms. Okay, so for the person who was asking what is the difference, like how do I know if it's a like or an unlike term, let's look at this question here. Remember this question, we got to this part and we had 5x minus 3x squared, and then I said, are these like terms? And then we concluded these are unlike terms. Why? It's because the variable x, though it is the same, look at the exponents. Okay, we know that if we write the exponent for x here, it's 1. If we write the exponent for x here, it's 2. So because the exponents are different, it makes them unlike terms. Okay, so hopefully you guys understand that like I said, terms are separated by a plus or a minus sign. How do you know terms are like? You look at the variable and the exponent. If the variable and the exponent are the same, then you know it's like terms. But if the variable and the exponent are not the same, then we know it's unlike terms. There's a rule that you learned in grade 8 and 9, and that is we cannot add or subtract unlike terms. Remember what I said? I said you cannot add or subtract the unlike terms. Okay, so that's very important. So here, look at this one, for instance. 5x minus 6x cubed plus 9x squared minus 12x squared y plus 6xy squared. Now, look at these last two terms. This is x squared y. This is x y squared. X has an exponent 2, but this x has an exponent, we know it would be 1. This y has an exponent 1, and this y has an exponent 2. Are these like terms? No, they are not. Okay, because their variable and exponent are not the same. Okay, 5x, 6x cubed, 9x squared. Are these like terms? No, they are not, because their exponents are different. Even though their variable bases are the same, but the exponents are different. This is 1, this is 3, this is 2. And then maybe someone will say, but what about these two, sir? I mean, this is 9x squared. This one is also 12x squared. But what makes it different? It's because there's a y here, all right? There's a y here and there's no y there. So that is what makes the terms unlike, okay? The terms are unlike because there's the variable y here, but there's no variable y here. So we cannot add or subtract these unlike terms, okay? So variables and their exponent make terms like or unlike. Okay, please, people, because what's dangerous or what's sad is that many learners, they'll say 5x minus 3x squared, 36x squared, and they will subtract this. And I sit there and I'm like, didn't you do grade 8, guys? Didn't you do grade 9? Did grade 8 and 9 do anything to you guys? So please, whatever you learned in previous grades is important. Okay? This is pure maths, it's not maths lit lunge. Right. Okay. Next question that I want us to look at for today, just another mixed example, unlike the examples that have been done before. Okay, here's a problem here. Okay, you're very welcome. Look at this one, look at this problem. Okay, let's just write this here. How many terms in the expression? Now, minus x is multiplied bracket to x minus 2y is multiplied to 4x plus y squared. So how many terms do we have in the expression? This is one term. One term. One term. Okay, one term. Now, how do we proceed? Now, really, guys, it's up to you how you want to proceed, right? And there's generally really, like, you could approach it in two ways. You could, if you wanted to, take this negative x and multiply it to this bracket. After you are done with that, then you can take what you got here and multiply it to 4x plus y squared. Okay, or you could, and I'm going to look at this approach, I'm going to look at both approaches. So let's just say minus x, let's put it there and allow it to wait. And let's focus on the binomial by a binomial. And then we'll take care of the negative x later on. Let's look at the binomial by a binomial. Okay, so this is something I'm deliberately doing. I am multiplying the binomial times the other binomial. And when I do that, remember, what do we remember? FOIL. In other words, we multiply the first term, distribute x to 4x, and then distribute x to y squared. Using, so distributive law using SNL. In other words, we multiply the sign first, then the number, then the letter. Okay? Alright, so let's start with the binomial by binomial. Negative x is just waiting there. Let's wait for it. Let's keep it there on the side, and let's just multiply these two first. So x times 4x. What's x times 4x? Let's start with the sign. Positive times a positive is positive. Then let's move on to the number. There's a 1 there, guys. 1 times 4. What's 1 times 4? It's 4. Then let's move on to the letter. What's x times x? We keep the base x. We add the exponent. You know there's a 1 there and there's a 1 there. That means 1 plus 1. Are we together? All right. That's how we would find x times 4x. Now I know some of you have already written 4x squared, which is great, guys. Remember, I'm just doing this for the purpose of explaining, because I've noticed that many people don't take into consideration that when you are multiplying same bases, you keep the base, you add the exponent. So I'm doing that for the purpose of explanation. I'm writing this 1 plus 1 deliberately as an exponent. Let's move on to the next one. X times y squared. So sign positive times a positive is positive. So our sign is taken care of. Let's move on to our number. 1 times, there's a 1 there. What's 1 times 1? It's 1. Then let's move on to the letter. X times y squared. Remember, with the letter, we combine the different letters together with their respective base and exponent. X is x, y is y. Combined, because multiplication combines letters that are different. So we have xy squared. Let's move on to the next one. So we are done with x. We've distributed x to the two terms. That's done. Now it's time to distribute negative 2y first to 4x and then negative 2y last to y squared. Let's go. Negative 2y times 4x. Negative 2y times 4x. What's negative times a positive? Negative. Okay. Then what's 2 number? 2 times 4, it's 8. Then what's y times x? Remember, the order of the letters doesn't matter, but I tend to write in alphabetical order, so it's going to be negative 8xy. Good job, it's slash. Then last but not least, not necessary success, you can just write x, obviously, you know that, but I'm just writing it there so that, like I said, for the purpose of those who are tuning in and they're like, okay, please understand. You guys are at different levels of understanding, so I'm doing that so that we can have that, okay? Then negative 2y times positive y squared. Sign, negative times a positive, negative. Then 2 times the coefficient is 1, 2. Then y times y squared. Y to the power 1 plus 2. Okay? Bracket closed. Okay, I see people know each other. Negative x. Okay, so the 4x, remember, that was 4x squared plus xy squared. All right, that 1 is always there. Even if I don't write it down, it's there. Just as long as we know it's not 0, it's 1 that's there. Okay, minus 8xy minus 2y to the power 3. Do you guys see that? So that is my the binomial by a binomial. That is the terms that I get. Are there any like terms inside the bracket? X squared, xy squared, xy, y cubed. Any like terms inside the brackets? You can clearly see, guys, that there are no like terms. So that means that I cannot add anything with each other inside the bracket, because there's no specific term that has the same variable and exponent exactly, right? Can you see that? I hope you guys can see that there are no like terms. Okay, now we've done with the binomial and the binomial. Now we can take the monomial, the one term, and then distribute it to how many terms? 1, 2, 3, 4. Negative x was patiently waiting to be distributed by multiplication to all 4 terms inside the bracket. Okay, all right. Please, people, this is not something that you must do when I'm doing this because I want you to see that I'm going to now take negative x and multiply it to how many terms inside the bracket? 3, 4 terms inside the bracket using S and L. So once again, distributive law. I'm going to distribute negative x to all 4 terms by using sign, number, letter. I'm going to multiply the sign, then multiply the number, then multiply the letter. Okay. Yes, we call this one term because of the bracket. But remember, inside the bracket, there are 4 terms. So all in all, the expression is 1, right? Because brackets combine terms. So yes, let's distribute. Negative times a positive, key negative. Number, 1 times 4, key 4. X times x squared is x to the power 1 plus 2. Let's not forget that, the addition of the exponents. Okay. Next term, negative times a positive, negative. X times x, x to the power 1 plus 1. And then we have the y, which is y squared, because it is the only variable that is alone. X has a complementing variable base. So base times base, we keep the base, we add the exponent for x. Okay, and then y to the power 2. Are we together? All right. Then negative x times negative 8xy. Negative times a negative, that's positive. 1 times 8, that's 8. X times xy, x to the power 1 plus 1 with our y. Okay? And then last but not least, negative times a negative for the last term, that is positive. 1 times 2, that's 2. X times y cubed, x, y cubed combined. Distributing that negative x removes the bracket. It's no longer there. Now I can write my simplified answer. Negative 4x cubed, rogered. Negative x squared y squared, rogered. Plus 8x squared y, rogered. And then last but not least, plus 2xy cubed, rogered. Are there any like terms in my expression? Can I add any terms here? Grade 10. I've also picked up that when there are brackets, it means the end answer won't have brackets. Yes, Olerato, you... Okay, I'm glad you're learning what you're learning because, yeah, that's more important. Okay, no likes, so no like terms, guys. So that means we end right there. Don't want to become romantic here and want to add things that don't add together, you know? Yeah, there's no matches, guys. If we don't match, we don't match. Don't match. So please, if we don't match, we don't match. Unfortunately, it is what it is. That's how life is sometimes, guys. Like, I mean, yeah. Please, please, please. Don't force matters. Let's not force matters at all. At all, at all. Okay? Yeah. Done in another way, of course. Like I said, someone else could have decided to, let's just check this way out. Someone else could have decided to do the following instead of what I did here above. Someone else could have decided to do this if they wanted to. Okay, because it's always, you know, remember multiplication is commutative. So in other words, the order, you can decide to multiply this with that first, put it in brackets, and then take this and multiply it with that. So we could have done this if we wanted to. Negative x times x is negative x squared. All right, I'm just gonna move right. You know what's negative times a negative, positive is negative. 1 times 1 is 1. X to the power 1 times x to the power 1 means x squared. Then again, negative x times negative 2y. Negative times a negative is positive 2xy. Okay, and the reason why here the bracket is not removed is because, remember, this is a bracket that's supposed to be multiplied with this. So all you've done here is you've taken the negative x, you've multiplied it with this bracket. But remember, this bracket was waiting to be multiplied with this one anyways. So you multiply the negative x with this x, the bracket is kept, and then from here you take binomial and you multiply using FOIL. DL using FOIL. Okay, does that make sense, guys? So this is another approach, same question, just different approach, because multiplication is commutative. I hope that makes sense. The order, you could have multiplied the first two, then like we did with this problem, multiply the last two and then negative x later on, or take the negative x with the first bracket and then multiply with the last bracket after that. I mean, it's really up to you. The final answer you're going to see is going to be the same. So let's go. Now we distribute negative x to 4x. Negative times a positive, negative. 1 times 4, be 4. X squared times x, we keep the base, we add the exponents. All right. Distribute negative x to positive y squared. Negative times a positive, negative. X squared, y squared, because the terms, all right, variables are different, so that we combine the variables. Then 2xy times 4x. Positive times a positive is positive. 2 times 4 is 8. Xy times x. Remember, the x, the bases x are the same, so we keep the base, we add those exponent, and then the y is combined to the x to the power 1 plus 1. Then last but not least, 2xy times y squared. Positive times a positive is positive. 2 times 1, the number is 2. Letters xy, y squared. Remember, the x solitary, he's alone, he's single. Y and y squared, there's some sort of match with the multiplication. You keep the base y, you add the exponent 1 plus 2. So finally we get negative 4x to the power 3 minus x squared y squared plus 8x squared y plus 2xy to the power 3. If you look at the answer here and you look at the answer there, it is exactly the same thing. All right, two different approaches, but at the end of the day we get the same answer. Why? Goes back to this thing, guys. If I had 2 times 3 times 5, remember, I could multiply this 2 and this 3 first if I wanted to. 6 times 5, which gives me what? 30. Or same answer, 2 times 3 times 5, I could have taken the last 2, kept the 2. What's 3 times 5? It's 15. What's 2 times 5? 15. It's still 30. Do you see? So the order, I mean, what you choose to multiply first, if there's multiplication throughout, it doesn't really matter. Okay, you will still get the same sweet, beautiful, amazing, glorious answer, which is basically indicative of this. Okay, because it was one term. Please, people, let's get into the habit of first checking how many terms do you have in the expression. Then apply the relevant approach with that particular question. Don't just jump in. You know, someone who doesn't care about maths will say 5x minus 3x for this first question and butcher the question like nobody's business and get something completely off the rails. And it would be very, very, very disheartening. Okay? Very, very disheartening what they would get. Moving along. Okay? Alright. I think I'm going to do one more. Alright? Then I'm going to give you some challenge questions to do for the rest of the session, which means I'm not going to jump into factorization as of yet. You need to make sure that this algebra is mastered, guys. If you master this algebra, then everything else that comes will not be as tough. You guys need to make sure, though, that this year you need to master the algebra. We're not going to do factorization today. Please, people, just hang on, okay? Please hang on. That's why I was saying that when you guys realize or notice that there are particular things that you are struggling with, if you have chosen pure maths as a grade 10 student, please, if you can see already that, hey, this for me will be too much, don't be, factorization will be done tomorrow. Please, guys, let's just, because we want to master this part, okay? And I just want to do one more. Same time, guys, same time, 8 o'clock. Okay, here's another one. Let's look at this one. Yeah. So once again, all right, look at the first bracket. This is a binomial. And then look at the last bracket. This is a trinomial. So we have 2 terms by 3 terms. Then we have a minus sign here on the outside. Minus on the outside. So once again, what do? We can go ahead and take the binomial and multiply it by the trinomial. Okay, so which would mean we distribute the 1x right throughout. Okay, very, very importantly. And then after that, we'll distribute the negative x over 2 right throughout. Okay, and then after we are done with that, keeping it in brackets, we'll take the negative sign and distribute it to what we will have got inside this big bracket. I hope that makes sense. So this is binomial by trinomial, just with a bit of an addition there with a negative. Remember, guys, if there's a negative sign here, it means that this is negative 1. All right. Okay, so let's go. 1 over x times 1 over x. So people, hopefully you guys understand that 1 over x times 1 over x, okay, is simply, with multiplication, you multiply the numerator. What's 1 times 1? It's 1. Okay. And then what's x times x? It's x squared. Okay. Remember first that before you go into the whole understanding of LCD, the first thing you need to apply is the distribution of the binomial by the trinomial. Are you with me? So 1 over x times 1 over x. 1 over x times 1 over x. Multiply the numerator. 1 times 1 is 1. X times x in the denominator is x to the power 1 plus 1 in the exponent, which is 1 over x squared. Are you with me? Because you're multiplying the numerator together. What's 1 times 1? 1. Then you multiply the denominator. This is multiplication, remember, guys. X times x in the denominator is x to the power 1 plus 1, which is x to the power 2. Okay, so minus 1 over x squared. That's 1 over x times 1 over x. The next one, 1 over x times x over 2. 1 over x times x over 2. Please take note, guys, the multiplication here. Yes, some of you will say 1x x over 2x. All right, but remember, the x and the x, if there's an x in the denominator, what's x divided by x? Obviously, this would be cancelling x and x. You are left with 1 at the top, 1 at the bottom. In other words, that's 1 over, what's 2 times 1? That's 1 over 2. Okay. Yeah. So 1 over x times x over 2 is equal to x over 2x. 1 over x is x. 2 times x is 2x. But then the x and the x, what happens to them? They cancel. Or in other words, x divided by x gives you 1. All right? 1 at the top, 1 at the bottom. So the answer will be 1 over 2. Okay. Very, very important, people, this part. Or some people would have done the cancellation. They would have seen that, oh, there's an x here, there's an x there. X goes into x once, x goes into x once. And then they do the multiplication. 1 times 1 is 1. 1 times 2 is 2. Okay. So basically, the approach here, there could be 2 different approaches. 1 over x times x over 2, where you just multiply the numerator, you get x. You multiply the denominator, you get 2x. And then the x and the x divided by x will cancel. You're left with 1 at the top and 1 at the bottom, which leaves you with 1 over 2. Or you can do the obviously the cancellation, cross multiplication, x goes into x how many times? Once, and x goes into x how many times? Once, because there's a highest common factor, which is x. Then it leaves you with 1 times 1, which is 1, 1 times 2, which is 2. It's still 1 over 2. So our answer then, the follow-up answer is 1 over 2. Okay, right? So 1 over x times 1 over x gives us 1 over x squared. 1 over x times x over 2 gives us 1 over 2. The last one, 1 over x times 1. Positive times a positive is positive. 1 over x times 1 gives me 1 over x. Okay? Yeah. We've distributed the first term to all 3 terms very successfully with right answers. Right? And I'm 100% confident in what I've written down. Then now we're going to take negative x over 2 and distribute it to the 3 terms. So let's do the same thing. Look at this x, look at this x. This one is in the numerator, this one is in the denominator. So what will happen? Those will cancel out. We're going to be left with 1 and 1. So our answer will be negative 1 over 2. Okay, so I'm going to write it down here on the side so that people can understand who didn't understand. Negative x over 2 times 1 over x. Check this out. Okay, this x and this x, because this x is in the numerator, this one is in the denominator, x divided by x is 1, which therefore means negative 1 times 1 gives me negative 1, and then 2 times 1 gives me 2. So I have a negative answer, and it's negative a half. Okay, so I have negative a half there. Okay, hope that makes sense. Then negative x over 2 times positive x over 2. What's negative times a negative? Negative times a positive? Negative. What's x times x? In the numerator, x squared. Over 2 times 2 in the denominator is 4. So I have x squared over 4. X times x, x to the power 1 plus 1, which is x squared. Then 2 times 2 in the denominator is 4. Then last but not least, minus x over 2 times 1. That gives me negative times a positive is negative. Then x over 2 times 1 gives me x over 2. Okay. Now, isn't that cool or what, guys? Now, before I take the negative 1 and distribute it, I just want to check inside if I have any like terms, right? Which is very important. 1 over 2 minus 1 over 2 will give me 0. Okay? I have x in the denominator. There's no other term with x in the denominator. I have x squared in the denominator. There's no other term with x squared in the denominator. I have x squared in the numerator. There's no other term with x squared in the numerator. I have x in the numerator. There's no other term with x in the numerator. So it's these guys. Half minus half is 0. So I'm left with 1 over x squared plus 1 over x minus x squared over 4 minus x over 2. Okay? Then take the negative and distribute it to 1, 2, 3, 4 terms. Negative 1 times 1 over x squared will give me negative 1 over x squared. Negative, distribute the negative 1. Negative 1 times positive 1 over x, negative 1 over x. Negative 1 times negative x squared over 4. Negative times a negative gives me a positive. And then negative 1 times negative x over 2 gives me positive x over 2. So I can leave the answer just like that. Yes, the signs just flip. You've got it spot on. Okay. Alright. Now, if you leave it like this, that's perfectly fine. Some people would go ahead and find the LCD. I mean, that's also fine. But if you leave it like this, it's 100% correct. Okay? 100% correct. Okay. Good people, that's pretty much about it for today. That's what I wanted to actually share with you. Lucy Masi, the question is, were you here from the beginning? Okay. Remember, if you went ahead and found the LCD, all right, lowest common denominator, half positive half minus half. What's half minus half? It's 0, right? That's what happened to the like terms. Half minus half became 0. Okay, and therefore, all I wrote as my next terms was 1 over x squared plus, that's gone, right? Those two are gone. Plus 1 over x minus x squared over 4 minus x over 2. Okay, I will be posting all of this in YouTube, don't worry. All of this will go up onto the YouTube channel so that you guys can rewatch it at your own pace and your own time and your own, yeah, it's very important. Okay, right? So like I said, for those people that, like I said, if you leave it here, you are 100% fine. You don't have to find the LCD. But those who insist that they want to go and find the LCD, remember, lowest common denominator is always the base with the highest exponent. Okay, so x squared, x, 4, and 2. So for your numbers, for instance, let's look at the numbers. Yes, Lunja, I do. If you look at the numbers, coefficient of x squared is 1. Coefficient of x is 1. 4 and 2. So for your numbers, what is your LCD for your numbers? 1, 4, and 2. Between 1, 4, and 2, what's the lowest common multiple between 1, 4, and 2? I'm sure you guys understand that the lowest common multiple between 1, 4, and 2 is? This is grade 10. Lowest common multiple between 1, 4, and 2. Definitely not 10, guys. No. Lowest common multiple between 1, 4, and 2. No, it's not 2, guys. Oh my goodness. Lowest common multiple. Guys, what are the multiples of 1? 1, 2, 3. What's the multiples of 4? 4, 8, 12. What's the multiples of 2? 2, 4, 6, 8. Lowest common multiple. LCM is 4. Alright? Sure. Lowest common multiple. So the numerical value of the lowest common multiple would be 4. What about the variable? If you look at the variable, x squared, x. Those are our only variables in the denominator. So when we identify the LCD for variables in the denominator, we go for the common variable that has the highest exponent. So our variable with the highest exponent would be x squared. So in other words, the LCD is equal to 4x squared. All right. So I'm not gonna go any further because there's gonna be a time when I'm actually going to teach you guys how to deal with addition of fractions. For now, I'm just looking at expanding, okay, and simplifying. But there will come a time when I'll teach you how to add and subtract fractions, and especially algebraic fractions. All right, and we'll take it one step at a time, nice and slowly, so that you guys can grasp it. But like I said, for now, with the expanding, if you get to this point, you're 100% correct, because all we are checking here is to check if you can actually multiply monomial by a binomial, monomial by a trinomial, binomial by a binomial, and a binomial by a trinomial. And whenever you have terms that are separated, being able to identify terms that are separated and apply BEDMAS where applicable, apply the BEDMAS order, and then make sure you don't add or subtract like terms. But when they are like terms, you do actually add or subtract them. So that is basically what I wanted to cover as a concept for today. Okay, everything else will follow up, and we will cover everything that needs to be covered at the relevant time. So I will post the game challenge that you guys need to do. Please, those who haven't joined the WhatsApp group for grade 10 as of yet, please guys, there are a couple of people that can assist you with that here who are on the live session. Please guys, just avail yourself. Okay, those people can actually assist. I think the greatest op can help you out. There's someone called the greatest op here on the page. If you guys can just raise your hands, like just send an emoji and say here, so that those people can actually send you messages on the side, and you guys can add all the grade 10 learners that still need to actually be added onto the YouTube, the WhatsApp group. And then, yeah, Landiwe is here, that he can help you out. Kutwano can also help you out. Tumelo, are you in the group already, or are you someone that actually needs to be added? Yeah. So Olerato is also there in the group. So all these people that are actually raising their hand, you can actually, like I said, message them. Yeah, follow them and then message them, and then they can add you onto the group. I'll be sending the problems that you guys need to do, because you need to practice more. You guys on your own need to practice. It's not good enough to simply just be here in the session, listen to me do it, because what you guys are seeing is my flawless approach to the problems. I am good at doing it. You don't know yet. So the way you are going to know you are good at it is when you actually start doing the maths and you start covering it. So please go ahead, guys, and do the maths on your own. And you guys are more than welcome to actually send me your attempts, either on TikTok as a message. You followed me. Maths is a game. You can send me your picture, the pictures of your work. Send them to me. I will give you feedback, during the course of today. Or you can actually, like I said, once you become part of the maths group on WhatsApp, you guys will be exposed to my number, and you can send me your picture attempts on there, and I can actually check you out how you did. Okay, so yeah, guys, thank you so much. Thank you for joining in. Tomorrow we'll do factorization. We'll start factorization, but for now, products. It's been products all the way. Okay, so I'll just give allowance, maybe 15, maybe 10 minutes allowance for just people to consolidate numbers and being added onto groups and all of that stuff. All right. Thank you for the follow. I think officially yesterday we entered into the 10K followers officially. So we are officially 10K followers for Maths is a Game. So the page is growing. Thank you for the support. Thank you for the follows. Also, do subscribe to the YouTube channel. I'll be uploading the session for today onto the YouTube channel so that people can rewatch the live session that was covered today. You can go onto my bio as well. You can click onto the YouTube link, the YouTube icon it's that red with the white play thing magic that you can click on, and yeah, you can just follow there. Okay, and please, guys, behave. I know you guys are getting connected and all of that stuff, but let's please behave and keep it above board. It's very important that we maintain a certain, they call it decorum and way of behaving amongst each other. It's very important, because at the end of the day, you guys will and can assist each other towards success, and you can actually be there for each other in the journey. The Great 10 journey is an exciting one, I think, very exciting one, and it can be a very successful one for you, but it needs someone who's committed, who's disciplined, and who will do what they need to do when they need to do it. Okay, so I was saying the game challenge problems, and you guys can attempt those at the right time. Good one, it's fine. I guess that's why it would be beneficial for you to get the YouTube channel, so that you can actually re-listen to the videos at your own pace, stop and start, type thing. You can pause when you want, re-listen to the explanation, and but I'll also try in the sessions to be a bit more slower, so that people can also catch on to what I'm doing. All right, I raised my hand in a mistake. Okay, guys, thank you again. Until next time. So tomorrow, same time, same place, same stinking things. Okay. All right. No, you're welcome, Trisha. You're welcome. Yes, Sulega, I do maths grade 11. Grade 11s are having a session at 1 p.m. today. And we're doing exponential equations. All the sessions that I've done previously are on the YouTube channel. So if your kid or whoever wants to catch up, you can always go to the YouTube channel. I've posted the videos of my previous live sessions for the other grades. Okay. I'm supposed to do grade 8 and 10 o'clock, but guys, it doesn't seem like that will be feasible, so I'm going to have to apologize to the grade 8s for that, because yeah, there's just home commitments I need to take care of. YouTube would handle Maths is a Game. Maths is a Game 5 to 7. You can go onto my bio. It's also there. If you click on the YouTube icon, it will send you directly to the YouTube page. Okay, but it's also called Maths is a Game, and I think we've just sort of like left the 400 subscribers. But you'll see all the videos that have been uploaded, at least the maths related ones, have a green icon, a thumbnail. It's a green thumbnail. It's like a chalkboard with a green chalkboard thumbnail, and all the topics for the different grades, I've listed them. I've listed the grade, and then I've listed the actual topic, right? So yeah, it would be of benefit. Grade 11 start with exponents at the beginning of their term 1 work. So it started with simplification of exponents. We moved on to exponential equations. We are busy with exponential equations now, and we'll continue in that fashion with the grade 11s. There's also grade 12. Grade 12 will be starting their first session today at 4 p.m. I'm so excited for that. In my school, I'll be teaching grade 12 next year, so they'll benefit a lot from that. So thank you so much, guys. Thank you for joining in. And Landi, I'll give you guys that are needing to consolidate the last bit of these contact details that need to be added in the group as appropriate. I had a grade 9 session at 7 today, so I always have a grade 9 session at 7 a.m. Just means you need to wake up. I know people are not used to waking up, they're used to sleeping, but you guys need to get into the habit, you need to get back into that habit again. I think what I'm going to do, I'm going to force the grade 12s to wake up a bit early. I'm going to start having sessions for grade 12 at 6 a.m. There's also a grade 9 group. Yes, there is, but unfortunately that grade 9 group, it's only when it happens that we have that. So like I do have grade 8 sessions, but unfortunately I was supposed to have one at 10, but now there's actually something that's calling for my attention, so I'm going to have to cancel the grade 8 session, and then I'll re-communicate another appropriate time for grade 8s. I'm very sorry about that. The grade 8s have been getting the back end. Haven't been able to successfully start very well. Sweet Candy, you need it for your son who's starting grade 8 next year. Okay, no, that's fine. So Sweet Candy, just follow me. Hopefully all of you guys who want sessions for grade 8 and all other sessions can just follow. I post the daily schedule sessions, but it's just that sometimes things happen, and for instance now something has happened that's out of my control, so I have to attend to it. So I can't have the session for grade 8 at 10 o'clock as scheduled. I'm going to have to find another time for that. Okay. But grade 11, I'm having you guys at 1 p.m. today, and then grade 12 at 4 p.m. So I'll see how I can squeeze in grade 8. Maybe I'll have an evening session with the grade 8s, Suleka and Candy. Maybe I'll have a grade 8 session later on this evening. Okay. Sure, no problem. Yeah. This page really got started, I think, towards the end of this year, towards your October, November. Yes, I'll have grade 11s at 1 p.m. today, launch. This page started, Yes, kindness. That's very true. And that would be helpful if they can share those with you guys. Muchidzi, I think you're gonna have to join the session. Send me your contact details on the TikTok inbox me your details, so that I can add you to the grade 11 group, or send you the link for the grade 11 group. Okay, and I'll try to attend to your DMs as swiftly as possible, guys, under the circumstances. Okay, I'll try my level best. Yeah. 。  . 。  。 。 . 。 。 . 。 . 。 . 。 。 . 。 。 . 。 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。
Q.
Yes, there's a grade 10 group. Grade 10 group is definitely operational. So I'll be closing the live at 10:02, guys. It's coming up. Okay, good. Thanks, Landi. Landi was such a rock star. He was really helpful. So much. Suleka, the group is on WhatsApp for the grade 11s.